O.J. Simpson was in the news all the time. And blue dresses were really important, although I don't really remember exactly why. So where was I at that point? So I was a rabbit farmer back in 1995, which is to say I was working for a company named General Magic that was creating a software platform in the mobile space. And before Palm OS, there were a number of mobile platforms, none of which were really successful. There was the Magic App devices that I was working on. There was the Newton. And, of course, there was the Tandy Zoomer, among others. Palm as a company at that point was writing software for these platforms, trying to make a living as a mobile software developer. The most famous of their software packages was Graffiti, this handwriting recognition software, which which was brilliant in its recognition that it's really hard to train handwriting software to recognize your handwriting. It's much easier if you just train the user to write everything the same way. And Graffiti did that thing. Everybody writes your characters that way, and it did pretty well. But Palm as a company and the founders felt like mobile could be better. There could be a better software platform for mobile. And so they made their own mobile platform. They made Palm OS and released it on the Palm Pilot. And they felt that they could do better, and they probably did do better because by 1997, by a year later, they had 66% of the market. And the question I'm asking is why? Why was Palm so successful when the previous platforms were not? And I think there's three really key reasons. The first is they knew who their competition was. And their competition were not all these other devices which were not that successful. And they also knew their competition wasn't the desktop computers of the time, which a lot of the other mobile platforms thought they were going to replace the desktops of the time. They were going to supplant them. Palm knew that they were competing against this, paper organizers. And paper organizers have a lot of great qualities. First of all, they don't lose data. Pretty much, if you have the organizer, you have its data. The second thing is they're fast. I've never had a paper organizer on which I could write faster than it could record what I was writing. And so the Palm platform was designed to beat paper, or at least be as good as paper in these key aspects. So if you have to think back to these devices at the time. They were relatively underpowered by our standards. They had 16 megahertz, 68,000 family CPUs. This model had 128K of RAM. 128K of RAM, I didn't say meg or gig. That's about 8 seconds of an MP3 on usual sampling rates. So it's a very tiny amount of memory. Their application design, their OS design to deal with these limitations was to only be running one application at a time, but to launch them extremely quickly. And to tie into that, they had these hard buttons at the bottom that were keyed to launch a particular application. So you could be in the calendar and decide you want to take a note and hit the note button and then take a quick note. I mean, it would come up as quickly as the screen could draw. You would hit the calendar and be back in the calendar. So it really took into account the limitations of the hardware to be a very fast experience on modest hardware. The second thing that was really, which I think caused Palm's success, was that they had built in database management into the platform. They had a database manager that none of us would probably think of as a database today. It was a flat file of binary blobs with some very limited indexing capability. But as primitive as it was something that developers on the platform did not have to write themselves. And even better than that, it was something that early customers of those developers didn't have to debug for them. So you could have all sorts of bugs in a Palm application, but usually the data would stick around even past the bugs. But it wasn't just persistence that this database, this common database format allowed. The other thing that it allowed was an architecture called hot sync. So Palm did some user testing of their devices, and they showed people the fast launching and the graffiti and all the fantastic calendar features. But the one thing all the users kept commenting about was, you mean I just drop it in this cradle and I hit this button and it talks to my computer and I get all my data? That was the thing that they were really excited about. And so what Palm discovered was that the killer app for devices at this time was connecting to the people's personal computers, to the data, to the precious data that they had on those computers at that time. So the hot sync sat on top of the database system. When records were changed, they could be transferred. The databases for applications could be backed up even if the apps weren't aware of it. And then the desktop interface for hot sync allowed Palm to connect with things like Sidekick, which was a very popular personal information management program at the time, or Microsoft Outlook, which astonishingly was a very interesting or important program at the time and still is. Other companies, General Magic, where I worked, and at Apple, actually contracted out this piece, this connectivity piece to the desktop. They didn't see it as key to what they were doing. And so these, as usually happens when something is contracted out, none of these things worked very well. So with those three things, I ask, how did the development community, how did software developers in general react to Palm OS? First of all, the number of developers and applications grew greatly over time. Websites on Palm OS popped into existence and really thrived. They were sort of the app stores of their time. Palm Gear in particular sold a lot of Palm applications to Palm users. And finally, Palm, by 1999, was extremely successful. The launch of the Palm 5 had been a big success. They had a ton of developers running a lot of apps. And then they created the Palm 7. It was a groundbreaking product. It was a wireless Palm. It communicated over the Mobitex wireless network. You could get email. And they invented this thing called web clippings that were sort of an access to the web through a proxy called palm.net. But the problem with palm.net and these web clippings is illustrated by this. On the left, we have a web clipping of abc.com. On the right, we have what the website actually looked like at roughly the same time. Web clippings were like the web, but they weren't actually the web. They were something different. And that was kind of the first sign that there was a problem looming for Palm OS that was going to be difficult to solve. But since the web has shown up at this point in Palm's story, I think we'll go on to Act 2 and talk about the web and the history of the web. So who remembers before the web? This was the interface to the internet. It wasn't always green, but it frequently looked like this. There were lines of numbers with instructions, and you choose them. And then this is where we are today. The interface to the web is rich. It's filled with interesting looking things and interesting interfaces and fabulous things we can do. And so the reflection here is, how did we get from green screen Gopher to here? It starts on this machine, which is a Nextcube, which happens to be the first web server that ever existed. And so I guess we can give Steve Jobs credit for the web as well, since that was one of his machines. A gentleman named Tim Berners-Lee wrote the first web server. And in fact, he invented the whole concept of the web in the definition of a thing called HTTP and HTML. And he did this work at a nuclear research lab in Geneva, Switzerland. The first version was working in this lab in 1990. And so I have to kind of stop here and tell you what these things are. This is an industry infested with acronyms. It's almost like there can be no successful technology without an acronym. HTTP stands for Hypertext Transfer Protocol, and it's how web servers talk to web browsers. There's a protocol in which you ask a web server for some content and it gives it to you. HTML is the contents of that protocol. It's a markup language for describing what the contents of a page should be. So the next version was released in May of 1991, and it got released by a gentleman named Paul Kuntz from the Stanford Linear Accelerator, traveling to Switzerland and seeing the browser in operation at CERN, and coming back to Stanford and setting up the second web server there ever was. So after that, the story moves here, interestingly enough, to the National Center for Supercomputing Applications. So how many folks here have actually seen this sign? I actually wandered over to look at it today. It's really, kind of a historic location, although some alumni told me that really wasn't actually the building. I walked through the lobby and I said, ooh, I'm in the building where the browser was made, and it's actually not the same building, but oh well. So that version, Mosaic for X Windows, was released, version 1 was in 1993. And I could swear to you there must have been a color version. I remember seeing a color version, but the internet search for images doesn't come up with a color version of it, so this was the best I could do. So it starts to look really much like a browser, and it's kind of sadly not anywhere near as good as the next version that Tim Berners-Lee wrote. But that's what it looked like in 93. So in 95, Mark Andreessen, one of the key authors of the web browser, graduated, at least I believe he did, and went to form a company called Netscape, and who first commercialized the web browser. And this is Netscape 1.0, and it's 1995. And for those of you who are quite young, this is actually a piece of magnetic media. It's called a floppy disk. Software used to be distributed on that, amusing as it may seem. Not to be outdone, Microsoft creates their own browser, sort of weird kind of genetics related to Netscape, and both sort of were based on Mosaic. This is version 1 also in 1995. So this starts the beginning of the first shot in the original browser wars. These two companies, lots of other folks were working on browsers, but these two companies are really duking it out. I mean, to the extent that there's some sort of inappropriate mascot combat going on in Silicon Valley in 1997. By 1997, both of these browsers, Netscape and Microsoft IE, are at version 4. So in 2 years, they've released 4 versions, or 3 additional versions of their browsers, which is sort of the beginning of Internet time. They added a lot of features to the browsers. Probably the most interesting one for this discussion is the language JavaScript, confusingly called JavaScript by Netscape, and JScript by Microsoft, who wanted nothing to do with a trademark war with Sun. These languages to allow you to write applications in the web page. And with that, the web as a software platform starts becoming pretty clear. The web itself grew very quickly. You can see the shape of this curve. If you're a hockey player or have ever pitched something to a venture capitalist, this is the kind of curve you like to see. There were already a bunch of big commercial and not so commercial successes on the web, all of these sorts of people. And Microsoft clearly viewed the web as a big threat since they took actions that led to the government filing this very famous antitrust suit against them. And this wasn't the first software platform that had threatened Microsoft, and not the first one they had managed to stifle with some rather fishy tactics, but this time Microsoft was stopped. They weren't able to take control of the web. So there had been online platforms before and online services before. And there's that floppy disk again. Now, you all must have seen one of these. Come on, every person in the country got sent one of those. But they weren't tremendously successful. And the question is why? Why is the web so much more successful than these online services had ever been? The first is ubiquity. And I'm kind of going a little backwards here, right? Because ubiquity is fairly recent. But, everything has a web browser. Desktop computers have web browsers. Laptop computers have web browsers. Smartphones have web browsers. Game machines even have web browsers. E-book readers, if you can imagine, have web browsers. And I don't even know what this thing is, but whatever it is, it has a web browser. So it's everywhere. If you're writing a piece of software, you want to deliver it to a ton of people, web browser, serving it on the web is an easy choice. The second characteristic of the web is openness. The web is this view source platform. From the very beginning, you had this ability, if you saw a web page or web application, you were curious how it was built, you could right-click, view source, and see what was going on behind the scenes, how it was implemented. This kind of openness really sped the development of the web as a platform. Developers could learn techniques easily, build on them, iterate on the platform. Coincidentally, Palm, the original Palm OS was actually fairly open in that while Palm apps didn't have a right-click view source ability, Palm did ship the source code for their applications with every SDK. So you could see how Palm was running these applications and learn from it. Also, web browsers themselves were pretty open. This is the source for the next version of the browser Berners-Lee wrote. He put it in the public domain. The source code for Mosaic was also available, the X Windows version for free and the other ones if you signed some licensing. So the web was very open. It also was very free. The web is a platform that is supported by hardware manufacturers but not controlled by them. If you think about Windows as a platform or Macintosh as a platform, there's a certain amount of lock-in. If you have a lot of software on a Mac, you can't really very easily switch. There's a lock-in there. But the web doesn't have a lock-in. I can be on my Dell netbook looking at Gmail, and then I can switch over to my desktop Mac and look at Gmail. It's the same thing. It has this freedom. And so how did that come about? Why do we have this situation where this platform is so consistent and available? Well, the first is the W3C. Back in 1994, Berners-Lee saw that this platform was going to be successful, and of course, there would be an attempt to hijack it by commercial interests. So he founded the W3C, which would define the standards for the internet, how web servers would talk to web browsers. And as a requirement for the W3C to accept any technology as a standard, it would have to be royalty-free and free of patent encumbrance. So it would have to be freely implementable by anybody who wanted to make a browser or a server. And that's kind of why the web doesn't have a logo. There's really no commercial interest who would brand it that can do so. But I feel like the freedom is really built into the DNA of the web, because fast forward to 2004 or so, a lot of people building browsers or building web applications felt that the W3C was moving too slowly and felt that they were moving in the wrong direction. And so they formed another group to try to push the standards in more the direction they wanted to, and that's the WHAT working group, for Web Hypertext Application Technology Working Group. There's those acronyms again for you. I guess nothing with 4 letters was any good was still left. And that's where there's the source of HTML5, which is kind of the next standard for what the web as a software platform is going to look like. So I kind of feel like the intersection between freedom and openness is the open source movement. And the web has really benefited from the open source movement to a great degree. So much so that there's this acronym that used to be the universal way of describing web application development, which was a LAMP, which stood for Linux, Apache, MySQL, and PHP. Or Perl, if you felt that way, or Python, maybe. But the really important point here is with this stack of technologies, all of these open source components, all you need is a hardware and connection to the internet, and you can be serving these web applications to your customers. There's nothing you have to buy. There's no software technologies you have to use. So, software developers, how do they feel about the web as a software platform? First off, the web became the user interface for the internet. You really don't see any green screens anymore. We have Gopher and we have FTP, but it's all inside of a browser. Secondly, the interest in developing software for these proprietary platforms, never tremendously great, dropped off completely. And those platforms, AOL, CompuServe, those sorts of people, really, their usage decreased greatly over time. So what else happened? So what else did software developers do with this web platform? One thing is it became fertile ground for innovation in software in general. Sort of Guy Kawasaki's, let 1,000 flowers bloom. Well, it was 10,000, 100,000 flowers blooming. All sorts of new technologies came. In fact, new languages that really hadn't gotten that much use, kept popping up. It was almost like the end of the biblical story of the Tower of Babel, when God came down and scattered the languages of man. God came down and created Perl and Python and PHP. But it wasn't really a tragic story because they can all talk via HTTP and HTML. So in fact, the scattering of the tongues wasn't really a punishment. It kind of reversed the course of language standardization that I remember at the time, where people would tell you, oh, don't bother with that crazy Haskell language. You can never get a job programming in it. And I don't hear that so much anymore because it's sort of been proven that that's not so true. In particular, Java, which was originally pitched as a desktop programming environment, write once, run anywhere, which any of you who have tried that know it's write once, debug everywhere. It didn't thrive on the desktop, but it has done very well as a way of producing HTML and serving HTTP requests. It's very popular in that use. Perl and Python and Ruby, a very obscure language from Japan that had been around since the early 90s but really had very few users, became enormously popular on the web, primarily due to the creation of the Rails framework. And even the venerable Lisp programming language had its moment in the web sunshine. I mean, who would have thought somebody would have paid $49 million for a program written in Lisp? It's the HTTP and HTML make this level playing field that lets software developers use the technologies they want to use. So it wasn't just new languages, and it wasn't just the back end where there was a ton of innovation. 2005 saw the wide deployment of CSS, which had been standardized quite a while before, but when it came out, it really changed the way the web looked. So here's Yahoo prior to CSS, and here's what it looks like after. It's really a much richer, much more interesting visual appearance. A great example of this, the power of CSS and the way that HTML and CSS are separate and yet combine to do interesting visual appearances, is this site, the CSS Zen Garden. It's a site run by a web designer where there's a static HTML content. It's always the same. And you're encouraged to submit style sheets and supporting materials to give it a different appearance. So this is what it looks like when you visit it the first time. If you click on links, you get different appearances. So this is another style done entirely by changing just the CSS. This is a completely different style, again, done just with CSS. Shakespeare said, "What's in a name? A rose by any other name would smell as sweet." But it turned out for web technologies, there was a package of technologies that smelled much sweeter once they had a specific name. And that name was AJAX, which stands for Asynchronous JavaScript and XML. Except it doesn't actually have to be XML and often isn't anymore. And it doesn't really have to be asynchronous. But no one's gotten rid of JavaScript yet, and the word "and" is still there. It was a phrase coined by a guy named Jesse James Garrett. And it was really talking about a bundle of techniques, many of which had been in use before. And as an example of the difference it made, think about MapQuest. For those of you who used MapQuest in the days before AJAX, you'd get a map, you'd click, the page would redraw with a new map. You'd click, the page would redraw with a new map. It was very slow and very unresponsive. And if you work with human interaction designing folks, or are one, and I work with them, I'm not one, you know that there's a very low limit on latency before users get very, very frustrated. And with a full page load, it wasn't really possible to meet those thresholds. But after AJAX, and a great example of that is Google Maps, there is no latency, or almost none. You can scroll the map all you want and keep scrolling. Some of the tiles might not be there right away, but you can keep scrolling. It's never ignoring you. It's always responsive to you. So AJAX really allowed the web as a software platform from a user interface perspective to approach parity with the desktop. Okay, so everybody get out your pencils. They told you there was going to be a quiz, right? Oh, wow. Okay, so we'll do this vocally. You can just shout it out. So here's a set of software that really changed computers and the way people used computers when they came out. Lotus 1-2-3, DBase, and Adobe Photoshop. So think back to that. And now, try to answer this question. Last 5 years, name a piece of software released in the last 5 years that has had that kind of impact on the way we use computers. Does anyone have any? Last 5 years, desktop software, Mac, Windows, Linux, anything, anywhere. Desktop application software, not OS. Did that really change it? We'll find out. Firefox. Okay, so I'm going to exaggerate and say that, interestingly enough, nothing that was released after the browser as a desktop application makes any difference at all. Like, the browser was the last piece of important software ever released. So I'm exaggerating a little bit for effect, but when you think about all of the interesting stuff that we've seen in the last few years, they're web applications. How many folks here use Gmail as their main email client? Yeah, so it's really telling that so much. I mean, there's Twitter that's gotten us typing 140-character messages. It's hard to argue about the impact of YouTube. That's been tremendous. I mean, Facebook is kind of a platform within a platform, which is, meta enough to make me a little dizzy. So it really feels like the web as a software platform has kind of won. It is the software platform of interest. So much so that if you think about a very successful recent entry to the smartphone market advertised their phone as, and I have to read, it was in a television ad, and I have to read this out as a quote, so I'm going to read it. This is not a watered-down version of the internet. or the mobile version of the internet, or the kind of sort of looks like the internet. It's just the internet. And so this company, famous for really great products, understood that what people wanted was to connect to the actual internet from their mobile devices. They saw that as a selling point enough to do a whole television commercial on that subject. And so that brings us to Act 3, and that's WebOS. And it's my third act tonight, and it's also Palm's third act. The first act we talked about, which was Palm OS. Palm's second act was this being the last incarnation of the Palm OS smartphones that started with the Trio. They were really the first to ship a capable, competent smartphone. Except there's one thing the Centro can't do. I carried this for a year when I joined Palm in 2008 in February. And it was a great smartphone, except Palm OS can't surf. And if you remember, the killer, or what I'm saying is the killer application has moved now. It's no longer the desktop computer. That's no longer where your precious information is to a large extent. That's not what it is. The connection to the web and to services on the web is where the killer app is. And Palm OS had a web app, a web browser. It was called Blazor. And the problem with Blazor is it was kind of like the web, but it wasn't really the web. If you really wanted to use it, you had to turn off JavaScript. You had to turn off CSS. You had to put it in fast mode. I don't know why fast mode wouldn't be on all the time on a web browser. And so customers were not satisfied. Sorry, let me go back and say, why is that true? Why did Palm OS not have a great browser? Well, there's two really industrial strength free browser engines. There's Gecko from Mozilla, and there's WebKit from Apple. And both of them depend upon OS features that Palm OS, like many of the OSs that were created in the early 90s, didn't have, such as robust networking, robust memory allocation, and vast amounts of it, cryptography. There's a whole host of OS services that you need to run these browser stacks, and Palm OS just did not have them. And now in the modern times, let's say 2006 or so, there's all of these competitors starting to come up that can do this. Well, 2 out of 3 of these can do it anyway. And these new platforms are more interesting to developers than Palm OS because they're really complete solutions to the customer. So interest in Palm OS as a platform is declining. Interest in the products are declining, and that's a big problem for Palm. And by 2006, 2007, efforts to update Palm OS had failed. And since I wasn't with the company at that point, I'm not entirely sure why that is. I would really love to know, and I'm hoping to some point find out what went wrong with, sort of doing Apple's trick of carbonizing OS 9, why that same approach couldn't have worked for Palm OS. But by this point, they decided against it. They decided they were going to start from scratch. They'd start with a blank page. They were going to create a platform that was aligned with the web. In other words, that was in harmony with the web. The platform's name was Nova, as I said, and the application environment was something codenamed Prima. And Prima had a few design elements. First of all, it used XML to describe its UI. But it wasn't XHTML. It was a proprietary tag format. It also used style sheets to describe appearance. But it wasn't CSS. It was a proprietary form of styling. So it was like the web, but it wasn't the web. And in March of 2008, Palm showed this platform to a number of developers, a small number, under non-disclosure. And all of those who had experience with web technology said, this isn't what we want. This isn't the web. We know what the web is. We like the web. But we don't know what this is. And by this point, iPhone is quite successful. They're saying, we're not interested in this platform. So at the same time, there's a number of engineers running around inside of Palm telling anyone who will listen that we should not just try to be like the web, but we should be the web. We should build this application platform on the same set of technologies that the web is built on. HTML, CSS, JavaScript, and these body of techniques that are referred to as AJAX. And so in April, a skunkworks effort is created, given sanction, to go and show, can you really do this? And this is the Roman goddess Luna, goddess of the moon. That was the code name picked for that skunkworks project. The mailing list on which everyone communicated was referred to as the lunatics, since Luna is the root word for lunacy as well. And there was a certain a certain level of insanity on thinking about taking this approach when, as people said at every opportunity, the ship date's not changing. We're still shipping this thing at the same time, even if we change the approach. So we had to do a demonstration for upper management, including the CEO, 2 or 3 weeks into this. And the demo was going to be, although they weren't quite this pretty at the time, the card mode that you've seen, with the activity cards where you can manage what you're doing, for those of you who've seen one of the WebOS phones. And a contacts application. It was filled with fake data, but it was going to show that we could scroll a list of contacts and everything would perform fairly well. So the night before this demonstration, an engineer and a designer, a CSS HTML expert, are putting together the pieces to make these applications. There's JavaScript from the developer. There's HTML, CSS from the designer. This designer goes home at 11 o'clock or so and takes a bunch of assets that he had for a calculator design and a calculator engine he found on the internet by Googling for JavaScript calculator. And he came up with a functioning calculator the next day. So in that morning, there were then 3 things to demonstrate to upper management, not 2. And so this was kind of what we hoped would happen by basing the platform on the web technologies, that we would be able to take advantage of the web as a great platform. And the effort worked. We demonstrated this product at CES 2009, January. It was running WebOS. None of this was faked up. None of it was really completely demo code. It was a functioning version of WebOS. So how is PalmOS different from WebOS? And how is WebOS different from most other mobile platforms? First of all, WebOS really is the web. It's built from the same pieces as the web. And its architecture is a lot like the web application architecture. At the bottom of WebOS is a Linux kernel and a Linux user space that looks a lot like any other Linux box you might see. Above it, we have a services layer that really is a lot like the back ends of web apps. It's doing things that the web sandbox, the JavaScript sandbox, doesn't allow us to do. And then we also have WebKit running sort of as the rest of the application platform. And then on top, we have JavaScript frameworks and JavaScript application code that kind of completes the platform. So this is really the same building blocks. This is the same stuff as the web is built out of. And it has a lot of benefits. The first is that there's a lot of information on these web technologies, on how to use them. Not many new platforms ship and have a bunch of documentation already available on how to program for them. And in particular, there's one book that's really a gem that I highly recommend you read, which is JavaScript, The Good Parts. And in fact, tomorrow you have an opportunity, I think it's 4 o'clock or so, to listen to the author, Douglas Crockford, give a talk on JavaScript, The Good Parts. Douglas is a fabulous speaker. I highly recommend you go see it. Another advantage is that the web technologies, for the most part, work on our platform. So there's lots of websites and blogs and techniques that are described, and they work on our platform. For example, this calculator demo, and this notion of, well, one technique that we use that's very common in web application development is we can have a developer create an ugly version of an application, functional but doesn't look all that good. And then a designer can come in and really make it beautiful. And they can do this all without any assistance from the developer. They don't have to ask them to, could you draw this differently? Could you draw that differently? They can alone really make things beautiful. And that, for us, since we were on a very abbreviated schedule, was a key feature to the success. Really, folks could work in parallel. Second is the tools. The tools that are used for web technology, web application development, do work fairly well on our platform. For example, TextMate, a favorite Mac text editor of mine, is very good at working on WebOS applications because it understands all the languages of the web, HTML, CSS, JavaScript. Many of our designers used a tool called CSS Edit, which is a live, interactive CSS editor. Lets you make little changes to the styles and see their outcome in real time. And since CSS can sometimes be a little tricky to figure out how to get to work right, that can be a real time saver. And lastly is the inspector. Anyone who's done web application development knows how to love the inspector, where you can right-click and look at elements and see what might be going wrong or going right with what you're doing. So the tools were a big advantage of this approach. In some ways, you can say a WebOS application is just a web page, but it's really more than just a web page. There's a user experience above your average web application that's provided by interpreting normal web interactions in some novel ways. For example, child windows. On the desktop, child windows aren't used that often, and when they are used, they're usually used for evil. They're either trying to sell you an X10 automation system, or more recently, they're trying to sell you a lot of other stuff. But when we use them to provide different kinds of user experience. For example, on the left here, we have these dashboard panels, which are parts of the notification system that's built into WebOS. The top are sort of just things that are happening. And the bottom is an actual live control panel for a music player. Those buttons are clickable. You can actually go next track, previous track. And the way it works is these are all just child windows. They're HTML, CSS, JavaScript, just like the rest of the app. You can put anything you want that can fit in 68 pixels or so right there. On the right-hand side, example of a pop-up alert, another usage of child windows. These are urgent alerts that need your attention. Same development technique, slightly different size, but it's the same sort of thing. So we're using the things that are already in the web platform in slightly different ways. But sometimes we need to go beyond what the web platform can do. We have to extend it a bit. And when we do, we try to extend it in a way that really is in harmony with the web. For example, there are some system features around power management or around location for which there are currently no standard ways of doing it in the web platform. And for that, we provide something that looks very much like an AJAX web service call, if you're familiar with those. You make a request to a particular path with particular parameters, and you get a response back. And so you can keep the screen on, or you can turn it off. You can find out where your location is. It's a very web-like way. So another reason why I believe WebOS is going to... Another really great thing about WebOS is as the web platform advances, as it gets better, WebOS gets better. And this was particularly true sort of in the middle of the development. We were using, and are still using, WebKit 3 as the basis for the platform. And WebKit 3 had a fast, for its time, JavaScript interpreter. But it wasn't really quite fast enough for the platform. And WebKit 4, which has a very fast bytecode JavaScript interpreter, wasn't ready to ship. We actually couldn't predict when it was going to ship, and unsurprisingly, Apple wasn't very interested in telling us when WebKit was going to ship. So it was a bit of a quandary. And then in September of 2008, Google announces Chrome, the new web browser. And inside of Chrome is a very fast JavaScript engine called V8. So one of our engineers integrated V8 into WebKit 3 and ran it on the platform, and we saw significant performance improvements to the point where it was fast enough to ship. So another benefit of being built on web technologies is there's a lot of advances going on in adding new features to the web platform. One of them is web workers, which isn't actually a bunch of guys writing web pages, but is a form of concurrency in the browsers. Right now, it's relatively tricky to do any kind of extended processing in a browser and not suffer from user interface lag. And so web workers is a technique by which you can have a certain amount of background processing. Another advance that's being planned is offline access, because only on TV do cell phones work everywhere. My cell phone did certainly not work here. So there's a set of technologies, app caching, offline storage, that are designed to let these web applications run when you're not connected to the internet. And those technologies will certainly be helpful for a mobile platform. Another one is CSS3. CSS3, so we saw with CSS2 how it could really transform in a static way what pages look like. CSS3 adds transformations and animations. And so on the left we have the WebOS clock application. And all of these images, the hands, the numbers, and everything is being done with CSS transforms. All those images are being rotated in real time that way. On the right we have the classic example of CSS3. These leaves are being animated and transformed using CSS3. So as CSS3 becomes available in browser engines, it'll really open up for our platform and the web a much richer, more interactive experience. So projection time. I have to ask, will Palm win its bet? Will the bet on WebOS be successful? So my assertion was that the rise of the web ended Palm OS as a platform, and that Palm had to create a new platform, WebOS. And WebOS is made out of the web. So is it successful as a platform? Is it a successful mobile experience? Well, at CES, the announcement surprised everybody and was greatly received. The Pre won a number of CES awards. for being the best product at CES. And so will Palm win its bet? I say absolutely. I really believe that the web is the winning software platform, and WebOS is the web. Questions? Yes. So nothing I say here should be interpreted as things that are actually going to happen at Palm, or I would have to just kind of shut up right now. But one thing you can say is that plugins are part of the web experience, right? The web is extended by plugins, and so you could imagine that that would be a logical way we would extend the platform. But other than what's been already announced about Flash, I can't say anything. Yes.
Do you contribute to the V8 framework since you use it?
The engine?
Yeah.
We would very much like to. And I don't think I'm at liberty to say why we would not. Sorry. Yes.
Thank you. The big thing that Apple is pushing now with the new iPod Touch and with the iPhone recently is games. And these unbelievable graphics that they're putting on a mobile device. And constantly, on all these blogs, you hear developers complaining that it's pretty hard to do that with JavaScript and CSS. So what's Palm's plan to stay competitive in this area?
I mean, what future unannounced things are we going to do?
No, do you think WebOS is capable of that with the current developer tools?
So I read the blog article about the difficulties of doing games, and the stuff about sound was pretty telling. The current implementation, we're using the HTML5 audio and video tag interfaces for sound. And my discussions with the self-aware games authors, they believed as long as the latency was very low, as long as when they said play on a tag, it played right away, that would be sufficient to do the sound stuff. So from a point of view of that discussion, I think the web platform will work. And I come from games from a long way back. Anyone here remember A Fool's Errand on the Mac? Anyone at all? Wow. That's a great game. On an 8 megahertz 68,000 with black and white graphics. So I feel like there are fun games that can be written in the platform. There are certain categories of games that the web platform currently cannot do, right? But there are proposals, for example, WebGL, that might enable it. And so when I looked at it, I'm not a games developer. So I can't look at WebGL or Open3D, I think is a competing proposal, and tell you if we had that, would there be good games? So I think we have, in this case, we're in some ways waiting for the community a little bit to tell us, what has to happen to the web as a platform to really enable these kind of games. I don't know that we have the expertise or even should attempt to say, here is how high-performance 3D games should be done in the web. Did I answer all your question that I can possibly answer? Thank you. Yes.
Is Palm currently actually in discussion with like W3C over the HTML5 spec? Like contributing or making suggestions?
It's very open, and I don't monitor the mailing list. The engineer who's most closely involved in WebKit, I haven't talked to him about it or want to, so I don't know exactly what he's contributing to. As you can see by the abbreviated schedule, we didn't have a lot of spare cycles to spend on things like that. I think it's extremely important, and I've recommended to my boss that we join ECMA. Douglas Crawford actually really recommended we do this and urged us to join ECMA to help affect the JavaScript standard, the ECMAScript standard. And so we're going to try and do that. But mostly, it's very important to us. We should be trying to affect it. And the great thing about What Working Group is it's very open. Anybody can go get on the mailing list and recommend things. And really, it's more just a matter of we're kind of, pedal to the metal right now, just trying to a large extent, deliver on the promise of WebOS. And so we just haven't had a lot of time to contribute, or to not really contribute, but interact. Yes.
So the 8,000-pound gorilla, of course, is the iPhone, and more importantly, the App Store. And I'm just wondering if you could talk about your strategy to deal with that. I'll just say one thing. It seems that the App Store has gotten so big at this point that in a way it might be its own worst enemy?
So we recently got two gentlemen joined the Palm developer team recently. Dion Almaer and Ben Galbraith. I just know them by Ben and Dion, which most people know them. They're actually two people who come from the web community. They founded the Ajaxian blog. And so they're trying to get our app distribution story really straight. So we did an announcement a week or two ago about the way our web application, or our application development was going to work. And the announcement there was, there's a web marketplace where you give us your app and we give you a URL, and you can put that URL anywhere. You can put it on a web page, you can text it to somebody, do whatever you want. When they click on it, they'll be able to install your app. It will be a very short period of time between when you submit the app and when we give you the URL. We're not going to review it for content. And then we're going to have our app catalog. And with our app catalog, there will be a review for content. And it's going to cost $50 per app. So $50 per app might give you the idea that we're going a different path than the Gorilla, which is to say, you can't really spam our app store with 2,000 applications with the hope that people will randomly buy them and give you some money, because that'll cost you a lot. So we're really, and here I'm paraphrasing, and I highly encourage you to read the real press stuff to know what the real story is, but we're really aiming at more of quality and less of quantity. What was the other thing? There's one other, and the other thing, if you think about that URL and how it works, there's nothing stopping somebody else from putting an app store on the platform. Oh, and the other part is open source applications. Ones that are following any generally recognized open source application will not be charged the $50. They can go into the catalog for free. And you as an application developer won't be charged the $99 SDK fee. If it's an open source application, it's completely free. Anybody else? Yes, sir. Or you just pick somebody by bringing them the mic. I don't need to point them out. I have no power to actually let you talk.
Thank you. So while we're still on the apps, as a developer, I have, iPhone, Windows Mobile, Android, WebOS, and who knows what else may come out, given you've shown that you, as at Palm, recognize the value in leveraging work outside of your own, which the App Store for Apple showed how valuable that was to them. Why should I pick WebOS? Why is that a compelling platform for me when I have to choose where I'm going to invest my time and effort?
That seems very much like a marketing question. So my feeling would be, right now, there aren't so many apps. So there's a little bit easier way to get seen. It's yet to be seen if we follow on our promise, but our promise of no review for the web marketplace and a relatively transparent review process. As a company, I would feel better if I were an independent software developer knowing I can ship my product, right? Not guessing that somebody reviewing apps will decide that my icon looks too much like some other icon and bump me back for 6 weeks. So that's another reason. If you already are a web application developer, there's a lot of leverage. You can it's easy for you to enter. If you're not that person, it's a little bit harder of a decision. And I guess it's something of a leap of faith, really. I mean, right now it's a small platform compared to the other ones, and so you got to decide whether being an early mover on the platform, if it's going to succeed, will give you an advantage or not. I think I personally feel, give us a couple of years, it'll be a very different story. I don't really feel like Apple has any magic ability in this space to create products that are better than everybody else. I mean, in some sense, there are some aspects of Pre that are better. There's some that are not as good, but I think we've shown a credible challenge.
My question is related to app development. I've got an entry in the app contest for this weekend, and I really enjoyed developing for WebOS. But my one complaint was that you leverage the HTML standard as the basis for designing the applications, but for most of the widgets that you use in the OS itself, they're just div tags, and I feel like my entire application is just like a series of nested divs almost completely. So I was wondering if within Palm, are there any efforts to use like the more semantic HTML tags as opposed to everything just being a bunch of nested divs?
So give me an example of a tag that would be a better use for any of the widgets than what we're currently using.
For example, like the list tag could be, I guess that's maybe not a great example, but headers for lists could be, H1 or H2 tags, and lists could be UL, LI, and so on like that.
Yeah, I think some of that was just inexperience. And some of it was that the benefit of the semantic markup is often on platforms where the user agent might interpret it differently depending on what is going on, and our platform at the moment isn't one of those. So it felt easier to not to try to make the decision about what should the right tag be for each of these elements when I couldn't see a lot of benefit for it. There are some things I actually feel a little bad about. For example, there's area standard for usability, and we kind of just didn't pay any attention to it at all. And it felt like maybe if we did, the thing could possibly be more usable for people with disabilities, and something to think about for the future. I was at Ajax Experience a few weeks ago, and there was a whole talk, and I just hung my head in shame the entire time. Anything else?
Okay. So do you have anything that's like the old Palm OS database?
So there's nothing quite like it. There's the HTML5 database, which seemed like a good idea to me when I first heard about it. Yay, SQL in the browser. And then I discovered that SQL just is a pain in the ass to use for data storage, especially for JavaScript, which, every object is like a hash, which means it can have anything in it. And a rigid table description and an object that can have anything in it is a really bad mix. So we tried to create this thing called the depot, which is an attempt to create one of these JSON-style databases like CouchDB on top of HTML5. And it works fairly well. You can put fairly large object trees into it and get them back, and it wraps all of the HTML5 underneath, and it's fairly usable. But it's not quite what we want. There really needs to be some. It's not as good as what the Palm database was to Palm at the time. We need something better. But it's usable for a lot of applications. The way it is right now, it's usable. I wouldn't say, oh, I'll come back later and see if they've got something better. It's it's SQLite underneath. If you're familiar with SQLite, you kind of know what's going on. One way in the back. I want Justin to get a lot of exercise. I'm going to take a chance.
Hey, I was just wondering, Apple, their iPhone is tied down to AT&T right now, and there's rumors that the contract could end, like 3 years after it started or 5 years, and the Pre is with Sprint. So, do you think in the future smartphones like this are going to move away from, carrier exclusivity?
So I don't have any inside knowledge of Palm or any experience with that. I don't work in that group. But the one thing you do know is it lets you buy a $600 smartphone for $200. And it's hard to imagine those sorts of things going away. I mean, really, they've worked extremely well. Apple's is unusual only in its length, right? Most carriers would get exclusivity for 6 months or maybe a year. It was very strange to have it be that long. And I think if it weren't so long, no one would be talking about congressional action on it. But I just for me personally seeing it, I just don't see how it changes. I don't think people are going to be happy to say it's $600 now and I get to pick my carrier. I don't know. I don't think so.
There's no denying that the web has been driving a major amount of innovation recently. However, it seems that in many ways a lot of this is going on despite the web, not because of it, because web technologies are basically a stack of hack upon hack upon hack, especially due to the legacy of the browser wars. Yes. Is the web really a solid foundation for a mobile device? And is it really a solid foundation for the next generation of applications in general, not just on mobile devices?
Yeah, it reminds me of the phrase, democracy is the worst possible form of government except everything else we've ever tried. So hack upon hack. That's true. And in fact, go see Douglas talk about JavaScript because he's a big fan of JavaScript and hates the browser. He'll tell you the DOM sucks, he says. Had a little argument with him at Ajax Experience about it because I said, once we get done redoing everything in Canvas, aren't we just going to have the DOM again? I mean, it'll suck in different ways, but it won't be better. So I think the answer is, yeah, there's a lot of hacks, but there's actually a process by, the HTML5, the What Working Group, there's a process by which we can all try to turn the hacks into something good. And I think that, big bang rewrites almost always fail. I mean, Vista comes to mind, right? And that was even nowhere near so ambitious. So is it the best? Absolutely not. Everything you said was true, but I think it still is the best path forward of all the things I've seen going forward.
On the Palm OS, I got the hard disk version of the Palm OS, and it all of a sudden went disk speed rather than RAM speed for reasons that made no sense. And, I've been a system programmer all my life, and I could not figure out why that page wasn't sitting there. So, that may be part of the problem. I mean, the guys that could do it disappeared or something.
Yeah, there's a whole history about Palm splitting itself in two to try to attract hardware licensees and then rejoining. I think that caused a lot of chaos in the technical direction. I wasn't there at the time. I don't really know anything about it, and I'd probably get in trouble speculating. So I can't say anything. But definitely, the Life Drive was definitely one of the first examples of it ought to have been great, right? And apparently it was not.
I really liked it because of the... And I wasn't able to...
Yeah. Anybody else?
Does the WebOS have a terminal that you can work with the Linux part of the...
So the developer kit comes with a protocol called Novacom, which is a sort of a connectivity over USB. And with Novacom, you can get a terminal on the phone via the USB cable. Surely you must have heard of the Konami code. I mean, we got all the street cred for the Konami code. The way you enable developer mode on a pre-device is you type, someone help me. I always have to go Googling to figure it out when I have to do it. So amusingly enough, the marketing folks said it had to be WebOS 2009, but both still work. Anyway, once you do that and you download the SDK and install it, you get Novaterm, which is a terminal on that. And it's Linux. It's BusyBox, which some folks within Palm think we ought to just be using the real stuff, not BusyBox. But it's a really pretty full Unix environment. And some people who I have taken no notice of at all have been doing some very interesting things by taking advantage of the very open nature of the platform and doing all sorts of exciting stuff. Anyone else? Great. Thank you very, very much for listening to that.